All right, hi guys. So this video is the first lecture of our water unit. And if you look on Google Classroom, it should look something similar to this. So under classwork, I recently posted the water unit resources. So you should see the first thing will be this water unit notes packet, and then underneath it should be this lecture. So it's probably called water resource lecture. So make sure that you've opened the notes packet, which should look something like this. And we're starting right at the top today, and hopefully going through the first page and a half. Okay, so let's get started. And again, within this unit, we're going to look at kind of three angles of water. We're going to look at water resources today, as far as where is water and a little bit about what are we doing with water. Next, we'll focus on water pollution, so basically like the human impact on our water resources. And then we'll also spend a few days looking at oil spills, just because it is obviously one major source of water pollution. So when we think about our water resources, and we think about, first of all, where is water? If you'll look at the first column here, so this is representing the total global water, all types of water all over the globe. And you can see, I'm sure you're familiar with this concept, that like most of the water on Earth is in the ocean, right? So it's obviously too salty for use. So a huge majority, like over 96% of the water, is found in the ocean. The rest then is fresh water. But if we pull just that tiny little bit of fresh water over and look at where is the fresh water, then you can see that actually a majority of the fresh water is frozen, totally inaccessible, right? So it's frozen in glaciers or ice caps, inaccessible to humans. 30% of the fresh water is found as groundwater, and then the other 1.2% is found in surface water. And today we'll kind of talk about what is groundwater and what is surface water and how we can access them. If we take a closer look at the surface water and kind of pop over here, a lot of the surface water, however, is frozen. So it's ground ice or permafrost. Permafrost is like permanently frozen water, not accessible to us. And then the rest is found in things like basically water on the surface of the planet. So lakes, swamps, streams, rivers, things like that, even including like the water found in living things, like all of the trees and the plants right now, atmosphere, and so on. So basically the point of this is to just put in perspective of how little water on the planet is actually fresh and accessible, a tiny amount. So we'll start by looking at groundwater. So groundwater really is just like the name sounds. So this is water found below the Earth's surface. It usually has gotten there because it started as precipitation that does not eventually evaporate into the atmosphere, flow as surface water, and so it eventually soaks down into the soil. Aquifers make up a portion of groundwater, and aquifers are what we call a sponge-like formation of rock. So it looks like a sponge, although it's not physically spongy because it's rock, right? So a sponge-like structure of rock, sand or gravel that holds water. So if you imagine a sponge, but now all of a sudden it's kind of made of rock or gravel, but it does have these pockets in these little areas that allow for water storage. So as water trickles and slowly seeps through the ground, it wanders through various materials. And at the very bottom of the aquifer, we call it a bedrock. So if you can look at the picture on the bottom here, you can see the hard bedrock. Imagine it's almost like a natural, like the bottom of a pool, right? So there's this hard bedrock with an aquifer area on geographic, like naturally occurring aquifer. that basically allows for water storage. So think of it as like a naturally occurring underground swimming pool, except the whole area here is actually, like water is being held within this rock formation, or maybe it's gravelly. So we use a lot of groundwater. So humans actually have gotten pretty good over the last however many years of accessing groundwater. Sometimes it's really simple and sometimes it is not so simple. So one way is by the use of natural springs. So natural springs are how water naturally comes. Groundwater naturally reaches the surface of the earth. Sometimes it quite literally looks like this picture on the top right, where water, you may be standing there. I mean, I've seen it hundreds of times. So I might be standing on a big hill, and randomly coming out of one area on the ground is just a continuous flow of water, literally just like this picture. You could go over pretty much any day of the entire year with a bucket, or in this case, just a little water bottle, and you could fill your water with that natural spring. Sometimes you'll find, like if you've hiked in Yellow Springs, hence the name Yellow Springs, there's lots of naturally occurring springs there just because of the geographic, or the geology in the area. And a lot of times now humans have kind of honed in on where the springs are. So the picture on the top left is not uncommon for what you'll find if you're like hiking around, where we've basically taken a location where there's a natural spring, and someone has kind of tied in some type of pipe to make it easier to fill. It seems silly for us because we live in Kettering, which we'll talk about in a second. But when I lived I lived on one farm, I lived in a teepee, and people so in the middle of rural Kentucky, they didn't have city water. So a lot of times they would find springs on the sides of the country roads out in the middle of nowhere. And for generations, people would haul water containers to, they'd go to the, one particular stream, fill up huge, I mean, like I'm talking truckloads. Some of the cisterns were, like half of a truck bed, like huge cisterns. And they would spend a couple hours a day hauling buckets to the truck from the spring back to the truck. So in some areas, I mean, not far from here, people actually still drink water straight from the, from a spring, and that's their only source. Other examples are, because you've probably heard of like hot springs, or even, I'm going to actually include like geysers here, right? So that was groundwater that's kind of made its way to the surface. Now, in the case of a geyser, it's been pressurized. So again, because of the geology in the area, that water has been a lot of times heated and very pressurized, which is why when it finally reaches the surface of the earth, it sprays really, really high. So most often now, residential, for a home to access groundwater, again, not Kettering because we get city water, but not far from here. Even in Beaver Creek, people have what we call wells still to this day. And so a well is really just a hole dug into the aquifer to reach the groundwater. So we sit on a really huge, wonderful, reliable, clean aquifer. It's huge, and I have a map of it, you'll see. Of course, in the old days, what we think of a well is like the top left picture, but that's really doing the same thing. So they knew that there was groundwater, they drilled a hole, and they built like a permanent structure to access the groundwater. The top right here, of course, is like an older fashioned version of a well. A lot of people still use this, especially like, if you live on a farm or something. But this bottom left picture is a realistic current day well that someone that doesn't have access to city water may have installed. So there's companies that come install this system, and that well truly does just drill down into the ground, access the water, and then it basically acts as a pump into the house. Here's a picture of our aquifer. So it is one of the largest, one of the cleanest in the entire country. So again, I stress that we are very, very lucky here. Our water, we don't have a reservoir. We don't have to deal with water storage. We have a really huge, reliable aquifer right below us, and it's huge. So you can see here's Dayton, here's Montgomery County, and you can see this aquifer underground spreads through multiple counties. So it's big. But you know what? I've never been able to find that Kettering had a water shortage due to an aquifer issue. Now, I know even just like last year, water treatment, we've had water treatment issues where we don't have clean water, but that's different. So what I'm talking about is like access to clean drinkable water. And so we've just always had and always, always have used water from the aquifer that's directly underneath us, wherever you're sitting today. Another really well-known aquifer, for example, is the Ogallala, which this is like the largest in the country. And you can see that it's just huge, spreads through multiple states. The problem is, if you notice where it is, for example, it's plopped right in the Midwest where there's tons of farming. So even this one, although it's massive, that region is just draining it. So basically, because of all the farming and all the people that are pulling from the aquifer, they've actually began to have some problems here in the recent past. So how do we use water? So when we think worldwide, what are we doing with water? Keep in mind that I always say we're very rare here in Kettering. So not far from us, people have water issues. And in the Ed Puzzle you should have watched was about the California drought. So even within our own country, we have major droughts, major drinking water issues. But when we think worldwide, keep in mind, 1/3 of the world's people are affected by water shortages. A lot of people don't have access to safe drinking water. 70% of our fresh water is used on agriculture. So a lot of the water goes towards just growing the food that we eat. 22% of our fresh water is used in industry. That means making clothes, making our junk, making literally everything. If you look around you, all of this requires water. It may be even just, there's tons of water used in even just generating electricity. So at the power plant itself, a coal burning power plant, which is where we get a majority of our electricity, uses water, lots of water to cool the machinery 24/7, just as an example. And then only 8% is used for personal uses. So it's really pretty small. So the amount that you and I directly come in contact with is actually pretty small when you think of the big picture. I think it's really important to notice that the food that we eat, the crap that we buy, all uses a very different amount of water. So the process, right? So if you look at this image, you can see, I call it thirsty. So you can see how thirsty beef is. So basically, for us to be able to produce a hamburger, it takes way more water than way more water than a potato, even way more water than chicken, right? So you can see this is just representing the amount of water needed to grow these foods, or raise or grow these foods. But you'll notice how heavy the meat is. So this is one major downfall of eating a lot of meat in our diet, is that it just requires so much clean water. And so when we think of the water that goes into making a hamburger, you have to keep your big picture. So think about where it all begins. It all begins on some type of grain farm, right? So let's just imagine corn. So all of the water that goes into growing the corn, and then we transport the corn, and then we begin the livestock farming process. Then we process. Imagine all the water that goes into the slaughterhouse, right? To try to keep the slaughterhouse, and keep it sanitized. I mean, just then we get it to Kroger's, and then think of all the water that even just like literally just like the, you know, the meat counter of Kroger uses. I mean, tons of water in the process. So again, one of the major downfalls of just eating lots of meat is that it requires literally, I mean, more than double, more than triple, more than quadruple the amount of water that a salad might, right? So and asparagus is even thought of to be like one of the thirstiest vegetables, for example. So you can see the difference between asparagus and an apple. And asparagus requires like double the water to grow than apples do. When we think about a pair of jeans, so when you buy a brand new pair of cotton jeans, it uses, to produce that pair of jeans, it requires 1,800 gallons of water. But think about where that's coming from. So all the water that went into growing the cotton, processing the cotton, making the, you know, forming the cotton into the denim itself, and then processing the pair of jeans and so on. So our clothes, like all this crap around us requires so much water just to grow the materials and produce them. Again, so 1 pound of hamburger requires about 4,000 gallons of water. And you imagine most of your families, if you guys do hamburger like for pasta or spaghetti or something, you probably do like a couple pounds of hamburger, right? So just the thousands of gallons of water in every meal we eat is just shocking to think about. One 12-ounce, regular 12-ounce can of pop requires over 16 gallons of water. Now that takes into account not only creating the drink itself, but also the aluminum can, right? So imagine all the stuff that goes into the pop, producing that, how much water goes into that, and then producing the aluminum can. The average bottle of water requires about twice the amount of water it can actually hold. So like in the lab that we did in class, if you imagine those bottles, it requires about double the water that it can hold just to produce the plastic. So this is so within the US and within households. So where does the average I wondered, where does the average household put their water? And this is you have to remember from what I just talked about, how this is such a tiny glimpse of the water that we actually use in a day, right? This is only the water that you're paying for. So when your parents get their water bill, this is what they're paying for, but keep in mind the amount of water that goes into the clothes you're wearing, the meals that you eat, the drinks that you drink. All of that stuff also requires like an even larger amount of water. Anyways, so I wanted to try to find somewhat of a reliable source of the breakdown in our homes. So you'll see for those of us that water lawns, about a third in our annual use goes toward lawns. I know some of you don't, I really rarely, if ever, water my lawn because of this. I try not to. I mean, I probably haven't in 2 years, maybe even longer. But some of us, you know, every morning in the summer, your parents get the sprinkler out, or you guys might even have like the automated sprinkler system. Anyway, so about a third goes to lawn, and that's also watering gardens and things like that. 20% goes to toilets, 15% to washers, so washing your clothes, about 10% or more to showers, 10% faucets, a lot to leaks. Leaks make up, right? Isn't it amazing that on average, 10% of every home, the water use in every home is for just general leaks. And you guys see my faucets in my classroom. I go over and cinch it down as much as possible. The plumbers actually were just in here, and I just can't get them perfect. And so I think a lot of people at home just deal with leaks. It's a lot cheaper, a lot easier, I should say, to just let that faucet drip than like paying a lot of money for a plumber to come fix it. So also, if you notice this stuff, we actually have a lot of areas that we can make changes, right? So if you think about it, I always tell my kids, if it's yellow, let it mellow. If it's brown, flush it down. So we actually save a ton of flushes at home if it's just peas. And my 4-year-olds, their peas are like tiny little peas. They hardly even count. So they're really good. I mean, they're good at flushing poops. And then we pretty much just save, you know, a couple peas here and there. And everyone always gets grossed out when they hear me say that, but it works. And it's like one easy thing for us to do. Okay. So then let's look at surface water. So this is water that you can see, right? It's on the surface of the earth. Examples of this are like our river systems, which I kind of include as like creeks, streams, and rivers. And then we'll talk about watersheds, the idea of a watershed as well. So the river systems are really created due to gravity. And we know that because of that, water moves downhill. And eventually, as water, moves according to gravity and elevation, it eventually forms into what's now pretty developed into a network of streams and rivers. We know you guys can kind of visualize that smaller streams and rivers eventually meet up, streams and creeks eventually meet up with bigger rivers, and bigger rivers meet up with even bigger rivers, and they kind of combine and dump into each other. And they usually large rivers usually dump into some type of larger body of water, like might be a lake or an ocean. So I usually in class, I make you literally sit here and look at your faces and make you close your eyes. And so I normally read this as you're just kind of sitting there, and I say, so imagine that you're standing at the mouth of a wonderfully roaring large river. Picture all of the individual water droplets that fell as precipitation or as irrigation at a farm or from washing a car at home. All of those water droplets have traveled over and under land to collect in small streams. From there, they eventually feed into this river you're currently enjoying. So basically, the idea of a watershed is the land that little water, all of those water droplets travel through. Okay, so that area of land that supplies water to a particular river system. So you are plopped when you're home, you are plopped in a particular watershed. All of the water that rains on your plot of land, wherever you live in your own little Kettering, that water drains somewhere, makes its way to some river. And so the area of land is what we call a watershed. And there's been this big emergence of watershed awareness in the last 5 to 10 years nationwide, and how important it is that we realize that the water that's falls in your backyard the next time we have a rain event, it makes its way to a waterway somewhere. So that's why, like back in the old days, people would just go into the backyard, like one little yucky corner of the backyard, and dump their used car oil or whatever, all these chemicals, thinking it was just kind of disappearing, right? And it disappears in their minds. But what they don't realize is that it makes its way into waterways, right? It doesn't just disappear. So the structure of a watershed really is like every single place on a map contributes to one particular watershed, which means every single person on Earth can kindly take care of the water and the chemicals that they release, knowing that they would eventually end up in a river or ocean. So here you can see, like Ohio, for example, is like on a larger scale, actually divided up into 2 big watersheds. And there's just this funny little watershed line that geologists have figured out. So northern Ohio actually does dump into Lake Erie. And then most of Ohio actually is what we call the Ohio River watershed. And for those of you that don't know, the Ohio River is what creates this entire boundary line of Ohio. So you can also see here on this big picture, this is the Ohio River watershed. So you can see it does include a chunk of Ohio, which includes us, but also many other states. So you can see the huge area of land that eventually dumps into the Ohio River. The Mississippi starts, this is the Mississippi River, starts up in Minnesota. I've been to the little headquarters, which is a funny story in itself. But this Mississippi River starts here and drains all the way down and makes its way down into the Gulf of Mexico. And look how massive the Mississippi watershed is. All of the rainwater would eventually make its way into the Mississippi River. And it's a really, really polluted river because of that. So I mentioned watershed awareness. So there's lots of organizations that are trying to basically like make signs, right? Put signs out there and make people aware that you've just entered the Paw Paw River watershed or whatever. So basically anything you dump, any pollution that, you know, when you have your picnic or you're doing whatever, it will make its way to that particular waterway. They are, I think I have a slide, but these watershed signs have made their way here to Kettering, Ohio. If you just pay attention, you'll see there's a couple different, I think, in Kettering, depending on which side of Kettering you're on. But you'll notice watershed signs here in Kettering. All right. I'm actually going to pause for a second. Okay. All right, so back to watersheds. That link used to be cool, but it doesn't really work anymore. Okay, so how do we use surface water? We use it in a lot of ways to benefit humans here in our country. So the number one thing, and again, we don't do this here because we sit on top of a massive aquifer, but a lot of other states have these huge systems of diverting water. Okay, so one thing that we do is divert water, which is basically moving water to a different place where humans can easily access it. We may move it to regions for agriculture or maybe move it to a region, a very highly populated region for drinking water. So you can see in the images here, these look like rivers, but they're actually very intentionally man-made channels, okay? So they're literally diverting water from one area like many, many miles to another area. There we go. The second way that we use surface water to our benefit is dams, okay? So dams are essentially like an obstruction place in a river or stream to block the flow, right? So if you imagine we have this river, we build a dam to stop the water, and that creates like a dammed up body of water. A lot of times we call that a lake or a reservoir. Sometimes we'll build that reservoir for drinking water. Sometimes we'll build the dam for electricity, sometimes both. So sometimes it's also like in regions that have really significant dry seasons. It just allows for water reservoir for water storage during the dry season for drinking and farming. But basically, if you imagine that we've stopped up, like the picture on the bottom right, if you guys look here, actually, I think, oh yeah, it is Caesars Creek. I cannot see those birds. That is Caesars Creek. So if you've ever been to Caesars Creek, one of our favorite places to go swimming and hiking. But this was a river. It was the Caesar Creek, sorry. It was the Caesars Creek. And it traveled through here and naturally kind of traveled in this direction. So they built up this massive dam and it stops the water, right? So in this instance, this body of water, we call it the Caesars Creek Lake, is only for recreation. It is not generating electricity and it is not used for drinking, strictly for recreation. In fact, there are no naturally occurring lakes here in Ohio. So all of the Ohio lakes that you've ever been to, like Indian Lake, St. Mary's, all of those are man-made for recreation. So dams are, there's lots of dams Okay, they're very widespread. We're actually really good at engineering a dam. We can make it whatever we want it to be. This one on the bottom left here is used for both storage of water and also generating electricity. But there's lots of cons. So in your notes, I think I just have a couple little areas for you to maybe pause this and maybe write in a couple pros to dams. So we have 80,000 here in the United States. We have lots of dams. So there's lots of pros, but there's also lots of downfalls. So dams are also thought to be somewhat controversial, especially in regions where they're being built. So if we look, you could imagine that the pros are that it creates a reservoir, right? So the reservoir could be used for drinking, for recreation. I've had lots of great times on Caesars Creek Lake. We can produce electricity with them. Caesars Creek also is really good at flood control in that region, but we also have dams downtown. We'll talk about, I think in a few days, about how after the major flood in Dayton, how many dams were created, I think like all over the region, just to manage water in case of another flood like that. And then cons, so huge bodies of water allow for huge amounts of water to be lost during via evaporation. That's one major problem. Wherever the lake is now, it was something. It's a huge percentage of dams were something before. Caesars Creek Lake, underneath the lake was actually a little town. So lots of people literally lose their homes. Towns get totally covered by these reservoirs. There's lots of stories you can read about, even like old cemeteries, burial grounds, historic sites being covered up by the reservoir or the lake itself. Dams collapse, right? So they get old, they're expensive to maintain, and they can, we have had, deadly accidents with dams collapsing. And then there's a whole ecological downfall. So if you imagine that the organisms have adapted to live in this river system, and all of a sudden humans come in and basically get rid of the river system, and now there's a lake, the organisms that were in that ecosystem die off, their populations plummet, and it can be an ecological nightmare. An example of that is the salmon. So you guys are probably familiar with this, but we know that salmon, for example, migrate up rivers for many, many miles to the same spot every year, and the same spot as their mother did, to mate and lay their eggs, right? Well, in lots of rivers out west, we have built dams so the salmon can no longer get to their breeding grounds. So we've seen a huge plummet in salmon populations because they can't breed. They literally can't breed. So that's one example of like an ecological effect. Now, I will say that we've actually gotten good at creating little salmon ladders, which are kind of like bypass channels around the dam, which allow the salmon then to kind of swim around the dam and then continue on their migration. Okay, so when we think of water depletion, with our growing human population in the country, but also globally, and an increase in the demand of clean, fresh water, our current systems are being depleted. So we're eating more meat than ever before. We're throwing away more food than ever before, and all of that food waste took up a lot of water to make. We're buying more crap every single day. That trend of buying crap, that trend is still exponentially growing. There's big, huge advertisement pushes, you guys, for like quick products, right? So they want you to buy something quick, but then be on the next. And our cell phones are one of the worst with quick turnaround. So you guys, I'm not going to actually show you the video because you should have watched an Edpuzzle video on the drought in California. But California is a classic example of one region here in the United States that has gone through some very severe droughts. There's basically the farming the farming, I'll say the farming and the huge population of people within California, and then a lack of drinking water, all just have, wreak havoc on the entire system. We have used and pulled and diverted the water from the Colorado River so immensely in so many places on that river. It is dry. It is, in so many ways, it just can no longer sustain the growing agriculture and the growing population that's trying to pull water from it. So here's just some examples of like normal, if you will, of the Colorado River. So here's what on the top picture, I'm going to say this is normal, but then it has gotten so low on a regular basis. Now this is during a drought, so this is extreme. This bottom left picture here, but you can see the before and then the during drought. You can see in the picture here, it's just some other examples of areas dealing with the drought. Here is the Hoover Dam. So you can see normally the Hoover Dam does produce hydroelectricity. 2014 was one of the years that they had really terrible drought. And you can see there's literally no water to even go over it. So not only is there not water for food and drinking, or household use, but even you can imagine that would affect the production of electricity, right? So lots of regulations in this during severe droughts. There's lots of regulations that go into basically mandating or like limiting, regulating water use. So there have been times where it's literally illegal to water your lawn, for example, because we need to save it for more important uses. So any solutions to depleting fresh water? Number one, the first thing that always comes up, people suggest, is desalination. So basically, if there's so much salt water on the planet, why can't we invest enough money and enough energy into being really good at getting the water from salt water? So, and that process is called desalination, basically separating the salt in the water from ocean water. The problem is at this point, it is still just so expensive. It takes a lot of energy to boil the water, to just constantly keep the water boiling, and then cool it. And the byproduct that we end up with is this really salty product that's very hard to make. They're kind of at a loss at what to do with this really salty byproduct. Do we just add it to a landfill and then that produces another problem? And the other issue is that the high salt content is just what's the word? Like not eroding, corroding. I don't know if that's the right chemical word I'm thinking of, but basically you can imagine the salty stuff is just building up onto the equipment itself, and I guess corroding away. So we're getting, it's like it requires constant maintenance, actually, because it requires constant maintenance and cleaning with really like heavy duty chemicals to just keep the salt buildup down. So I would love for this to be better, but right now it really just isn't. We're not very good at it. Now, I will say, when I say that, but there's 15,000 plants in over 100 countries. Not all of those are here by any means, but this is an area of a lot of interest and research. So this could be your field. This could be your thing. It could be great. The second thing is, okay, so how many times have I mentioned how much water our agriculture industry uses? But they're trying to get a little better. So some of the areas of growth are what we call drip irrigation system. If you look here, these are tiny little baby corn plants. And you can see the black tubing that really just skirts their little root system. So instead of like these huge, massive systems spraying water all over, you know, how many acres of corn, they tried to hone in on, right, getting more direct on where they want their water to be. And so way less water is lost to evaporation and just like making its way to places we don't want it to be, and then just immediately making its way into the drainage ditch or the creek or the stream or whatever. So some farmers are investing like a lot of money up front into this drip irrigation system. And then another thing, and I kind of like that in the video you should have watched about the California drought, was like talking about why are we trying to grow these crops? We can handle changing our diet if we need to. I feel like if it makes more sense to grow different crops, but that's the problem, is we have now created this society in the last 50 to 100 years, where 75 years, I'd say, where we had this expectation we should be able to go to the grocery store at any given day and get literally anything we want, right? Just this morning, honest to God, now that I say this, my kids were begging for watermelon. So I had to talk to them, give them this whole spiel about watermelon and how, you know, it's seasonal and it's such a big vegetable or fruit. It takes forever to grow even. So anyways, we just have this mindset that everything should be at our fingertips at all times. We should be able to go to Myers and get anything we want, and we feel angry if they don't have it. But why not kind of reverse that and eat on a more regional basis, or eat on a more seasonal basis, right? Eat what types of foods are being able to grow at that time, and even within your own region. It makes so much sense. But anyway, so we're trying to get better with that. Industrial solutions. So again, remember, a lot of our fresh water goes towards just industry of making all this crap that we buy and use. And they're finally getting to the point where they're learning how to reuse wastewater. A lot of times wastewater is just used to cool something, big heavy equipment or something. And so we're trying to get into reusing that water and using less. So just allowing the process itself to become more water efficient. Personal solutions, and then we're done. So the last thing is looking at things that personal solutions is in your life. Watering plants at night, that's my biggie. I get watering your lawn to an extent. I get watering flowers, right? But water at night, where less water is going to be immediately lost in the the heat of a summer day, at noon, water will be lost due to evaporation. So water smarter is what I always say. Choose climate appropriate plants. So a lot of times, if you go to Lowe's on a day in June, a lot of the flowers you see there, they're annuals, and they're not meant to live here. So they're not native Ohio plants. Like most of the plants for sale at Lowe's or Home Depot in the spring and summer are not adapted for Ohio summers. So then our parents are out there frantically watering every morning and every night or whatever to keep them alive. But why? Right? Those plants, there's no hope of them surviving the summer without being watered continuously. So why not be smarter? And one big push is just buying native plants. And one of the reasons for that is also it requires less maintenance because they have adapted to growing in our climate. Choosing low flow toilets and shower heads. I actually have low flow shower heads on TV, guys, and also low flow toilets. So when your parents go buy one, now they're almost all pretty efficient when you buy them, but you can even buy them. One might be a little bit more, I feel like $30 more or something, but it used half the water. I can't remember the exact gallon, but they're really pretty good, all pretty good now if you're buying a new toilet. Fix the leaks in your house. Shorten your showers, be more mindful about dishwashing. My new dishwasher, one of the reasons I bought brand new dishwasher is because it was just going to be so much more water and energy efficient. So I put everything in my dishwasher now because it's actually, I mean, from what I read, is way more efficient than me like hand washing my pots and pans and stuff, for example. And then of course, just stop consuming so much crap, be more mindful of the stuff that we're buying, buy used, eat less meat because it requires so much more water to produce. Okay, that should be the end of our first section of notes.